Alright, in the following diagram, segment KL is parallel to segment MN. Which of the following statements and reasons could be correctly used in proof that triangle AMN is similar to triangle ALK? Select all that apply. Okay, when it's asking me to select statements and reasons, I go to duplicate the tab. I bring it up over on the other side. And I select show all. And then I scan, since I see that similarity proofs right there, I'm going to scan until I see concept C. And scan to see if I have one set up kind of like this. Alright, this one is similar. I'm going to scan some more to just see if there's another one that's given, and there's not. So let's go back and see this. So the reason I'm saying this is similar is because it's saying that segment AB is parallel to segment DE. Well, they say right here that segment KL is parallel to MN, so that means we could put those chevron markings right there. I know it's not drawn to look like it. We did that on purpose. However, that is the given information. And then we have an example of one that we could use because there are side links. What I'm going to do though is I'm going to scan to step 6. Because it lists out all of these reasons, and then, so it fills everything in. So I don't know if you've noticed that in the show all option, but I could click show all and look at this step before so that I could go through and answer whatever step 5 was, if they're asking you to do that. So that's just kind of a tip to play with the system. Alright. So what I'm going to do is I'm going to look for the reasons and look for reasons here that are similar. And that is going to be helping me set it up. So I'm noticing that right here there's vertical angle theorem, and this first one says vertical angle theorem. I want to first check and make sure that these angles are indeed vertical angles. So this goes back to your information on what angles are. You can do a Google or determine it if you aren't familiar with it. I just remember vertical angles as the X, and they're top and bottom or left and right. So is AKL, well, it's right there and it doesn't even make part of the X, so I know that that's not vertical angle. So I know that one's not correct because even though the reason's correct, the statement's wrong. So let's see, this one says vertical angles too, so let's check and see if these angles are. So KLA, KAL, sorry, a little bit of dyslexia there. KAL is congruent to NAM. NAM, because they're vertical angles. Yep, those are indeed vertical angles. So this is one of the reasons. Alright, now I'm going to scan again. This next one says corresponding angles theorem. So I'm going to see if there's a corresponding angles theorem in here. And I'm seeing corresponding sides. I'm not seeing corresponding angles theorem. And it is actually talking about the exact same angles that were in the vertical angles theorem, so KAL and NAM. So I know that's not correct because we have the correct statement and reason on that one, so that one's off. So let's scan again. This one's alternate interior angles theorem, so it does show up, so that could be an option. The other thing that was leading me to cut this one off was that corresponding angles theorem isn't in here. So that was another way to just eliminate this as an option. So alternate interior angles theorem, let's make sure that these angles really are alternate interior angles. So We have angle LKA, LKA, so this angle, to angle MNA, MNA. Now remember, it says that segment KL is parallel to MN, so if you want, you can straighten this line out if it's going to throw you off, and just imagine that that's coming in like that for KL. So remember, it's this angle comparing to this angle, and it says that they're alternate interior angles, so are they on the same side of this transversal? Left, right. So this angle is on the left-hand side, and this angle is on the right-hand side, so they're alternate. And are they between the parallel lines? Well, this is the parallel line, and this is the other pair of parallel lines. And yes, they are between them, so they are alternate interior angles. So that statement is correct as well. And then we know that there's going to be one more angle, because to prove triangles are similar, you have to talk about all three angles being congruent and the side lengths being have a proportionality. So angle KLA is this angle KLA, and NMA, sorry, dyslexia is kicking in pretty good right now, NMA. So I'm just going to breathe for a second until I can switch that. Alright, angle NMA is right here. Again, these are parallel lines. They're drawn to throw you off. Just remember that they are parallel lines because that's what's given. We're talking about this angle and this angle. Are they on the same side, or it's given alternate interior angles? We're checking this statement first. So this is the left-hand side of transversal, right-hand side. One's on the left-hand side, angle right here. The other one's on the right-hand side, angle right here. So yes, they're alternate. And are they between those parallel lines? Yes, they are. So they are alternate interior angles. So that's the other statement with the correct reason. So now we have all three of our angles taken care of. That means we aren't going to choose any more that are talking about corresponding angles. The statement that segment KL is parallel to MN was very important because we used that in our alternate interior angles. Also notice that this statement starts off with what was given right from the get-go. And then remember, with similar triangles, it's to prove the ratio of corresponding sides. And if I scan right here, it says corresponding side lengths have equal ratios. It says it right here. A scale factor is the ratio of the length in the image to the corresponding length of the image. Whoop, that's not it. It's right here. Ratio of corresponding sides. So that is a correct statement. And that's how I would use this example to help me eliminate based on just looking for the reasons that were given in here and looking for similar reasons given in here.